Let's set the context for this video series. This video series is about building a large language model from scratch. Why are we doing this? To understand the science of LLMs. So today is day 0. What is the best starting point to understand why LLMs? The best starting point is start by asking why LLMs. But why should we start by asking why LLMs in the first place? Consider understanding LLMs as an equation. Left hand side of the equation is how LLMs work. Right hand side of the equation is why LLMs. You need to truly understand what you are solving for on the right hand side to fully understand how you are solving it. That is why we start with why LLMs. Now let's follow a structure for understanding why LLMs. We start with the sources closer to the truth, like OpenAI, Google, and Meta. We start by understanding why are they building LLMs, and then we go deeper till we get an objective understanding. Let's start with Google. Google's research team created transformer architecture to improve the accuracy of language translation. And OpenAI took this transformer architecture and used it to classify text based on sentiment. One of their earliest projects was to classify Amazon reviews as either positive or negative. And Meta took this transformer architecture and used it to categorize text coming from their Facebook newsfeed or Facebook Messenger. Translation, classification, categorization, all of these have one thing in common. We need to truly understand how languages work to do any of these things. So let's understand how languages work with the example of English. Let's start with words. Words represent basic ideas of what we see in the real world. Example, let's take the word cell. Cell represents the basic building block of organisms. Here is a crazy English fact about words. Total number of words in English language as per Oxford's latest dictionary is 600,000. Now, as per research studies, number of words actually used by all the English speakers is only 150,000, and number of words actually used by one English speaker during their entire lifetime is just approximately 20,000, and number of words actually used by one English speaker to cover 95% of their daily usage is only 2000. So in English language, you just need a small number of words to convey large amount of ideas. This is possible because one word can represent multiple meanings. Let's move to rules. Language rules help us to create sequence of words. This sequence of words help us to represent complex meaning of what we see in the real world. Example, see this sentence. Cell is a mass of cytoplasm bounded by a membrane. Each word in this sequence has a basic meaning. When these multiple basic meanings are joined together in a sentence, it represents a complex meaning. In this way, we can always generate infinite sequences to represent infinite amounts of meaning. This infinite generation part is efficiently done using a finite set of words and rules. How? It is because each word can have multiple meanings, just like how we just saw. Let's take the example of the different meanings of the word cell. In biology context, it might mean a basic unit of life. In electronics context, it might mean battery. Similarly, depending on the context, the meaning of the word cell changes. Now, the biggest question. How do each word decides what meaning it conveys in a sentence? Meaning of a word is determined by other words near it. We can write it as an equation. In a sequence, the meaning of a word is a function of other words near it. But why is language built this way? It's because universe is constructed this way. In universe, any real world phenomena is a function of relationship between multiple real world phenomena. So language, which is built to represent the real world universe, also follows that way. So every word is a function of a relationship between multiple words. If you look at this is a deterministic equation. But wait, everybody told me that LLMs are probabilistic. So let's break some myths now. LLMs are probabilistic, but that does not mean that the words form a random distribution. Language and words have a lot of deterministic structure. It's just that they are hard to find. So we assume that words have a probability distribution, and probability in this case is just a modeling assumption. Ironically, we use deterministic rules to predict this probability distribution. Also, just because we are predicting probability distribution does not mean there is no reasoning here. Predicting is a type of implicit reasoning. Our brain also does a lot of this implicit reasoning by predicting probability. Real problem with LLMs is that we can't interpret this implicit reasoning because this entire implicit reasoning happens in a multidimensional world. We will cover a lot about this multidimensional part in future sections. So, summarizing what we have covered so far, why do we need LLMs? The first reason is understand how the meaning of each word is determined by other words around it. Since we can't find a deterministic function, we approximate it using a probability function. Consequently, we understand the real world phenomena represented by these words. In this way, we understand a part of the universe. So, every component of LLM should be optimized for this understanding universe objective.